Now, the algae here and the water weed, these are the primary producers. They are basically the plants that trap sunlight to manufacture energy. Then these are fed on by this group of organisms, which also fed on this and the like. So we have a series of primary producers, number one. Then we have primary consumers, which are fed on by secondary consumers. And the last column that we have depicts tertiary consumers. So those are the trophic levels that we are looking at. One level, from one level to the other one, depending on the type of food. Then realize that our food chains are normally very short. As the energy is passed along the food chain, each organism uses some of that particular energy. So further along the food chain, the amount of energy actually reduces. Now, large amounts of energy is actually available for the producers, and therefore there are very many in numbers. Less energy is available for primary consumers, secondary consumers, and so on. So it therefore implies that towards the end of the food chain, organisms get fewer in numbers or smaller in total size. The loss of energy along the food chain also limits the length of the food chain, because not enough energy is actually left to supply the next link. Basically what we are saying here is that if you look at this representation that we have, now if you quantify the primary producers, this is the plant that we have, and look at the amount of energy that is being trapped, for example by this sunflower, we are quantifying that to be around 10,000 joules of energy. Now, the primary consumer, which is our locust, will feed on this. But now, if you look at the amount of energy that is being transmitted to the primary consumer, we only have 1,000 joules. From 10,000, there's a loss of 9,000 kilojoules. Then, if you move further to the next feeding level, so the consumer, you can only see that out of the 1,000 joules of energy that were initially taken in by the primary consumer, only 100 joules are being obtained by the secondary consumer. Finally, if you look at the tertiary consumer, it is actually able to obtain only 10 joules out of the 100 joules. So there is a lot of energy loss along the food chain from one trophic level to the other. Equally, as you look at the numbers, they're saying that in any feeding level, you realize that primary producers are many in numbers. So the loss of energy in these particular feeding levels limits the number, the population, or even the size of the organisms that are able to be in that particular region. Now, during the transfer of energy across the trophic levels, there is loss of energy in the form of heat, obviously from the process of respiration. Then there is also loss in form of excretion and defecation. All these three main ways actually accounts for a large proportion of the energy that is lost. If you compare the initial amount of energy obtained from the sunlight to that amount of energy present per any given trophic level. When organisms die, unfortunately, all the energy in them gets lost through in the process of decomposition. So as higher organisms happen to die, then there's a breakdown by fungus and bacteria. They are able to break down the food materials, and essentially the organisms we end up losing the amount of energy. Now this is actually another more or less of the same. It's a pyramid of energy flow. Now if you look at that particular structure, the shape of the energy flow is more or less of that of a pyramid. We call it a pyramid. So what you're seeing is at the base here, we have more numbers. So the producers are many. So the producers are largely, these are plants, they are more. As you move up the level, up the ladder, for example, primary consumers, these are primary consumers, the numbers become less, but the sizes also become bigger, become many, equally secondary consumers. The numbers small again, population there. If you go to the third degree, the less the numbers are more less. So the total outcome is more of what referred to as a pyramid. It's a pyramid structure. No wonder we are depicting is a pyramid of energy flow. We are using the same to depict. Now the large green representation is a primary producer. In this case, these are the phytoplanktons in a water body, trapping sunlight, of course, giving out a lot of energy, but they are also respiring, meaning we are losing energy in form of heat. So out of the 10,000, there's some energy being lost. Then primary consumers, zooplankton, the animals, they feed on these phytoplankton, and out of the 10,000 joules, they are only able to convert, they only able to obtain 1,000 kilojoules. Again, look at the numbers, the population, it's actually smaller. These primary consumers are fed on by secondary consumers, for example, the Nile perch, a type of fish. This population of zooplankton can only sustain a small amount, which are further fed on by the tertiary consumers, especially the human, feeding on this particular fish. You can see the amount of energy that is actually in kilocalories that's being transmitted from the original 10,000. A human being ends up with only 10 kilocalories out of the 10,000. So from one level to another one, there is obviously the loss of energy in form of heat, and that one is actually being affected by the process of respiration. There is also excretion and defecation as a process. Now when all these living organisms actually die, what happens? They decompose, and that energy is also released. No wonder you're saying that we end up losing our energy when these organisms pass on. The decomposers are able to break down the materials, and they are able to release the nutrients. But the good thing, the nutrients that actually, the nutrients that are released back into the ecosystem, they are recycled back, and the producers can be able to utilize the recycled nutrients and sustain a higher population of primary consumers once again in the ecosystem. Basically, they reduce the decomposing matter, recycle nutrients, and also minimize pollution. Lastly, I'll give you some questions, some activity. You'll be able to, I would want you to actually name the process by which energy from the sun is incorporated in the ecosystem, question number 1. And then part B, you explain the difference between the terms community and population, and of course giving appropriate examples. You can make reference to your biology textbook, TNB book 3. You'll be able to clarify a few of those issues that may not be all that clear. In the event there is an issue, you can also interact via the Google Classroom and be able to tackle whatever you have. Otherwise, thank you so much.